See, guys, we got a great group of guys here.
We got a good turnout, it seems.
7:01. I can give it 7:03.
We got 5 viewers or 5 waiting on YouTube. So
Recommend
looking
using
good.
Discord if you want to watch, because I think there's less delay between us talking.
And to add to that, so if you're not in the Discord, this doesn't matter. But the point is, pick one. Pick either the Discord or YouTube, but not both. And if you have both open, just make sure you mute one, because otherwise you're going to be hearing everything twice. You know the drill, people. It's the COVID-19 era arrangements.
Lou, I love. Lou, I was gonna say I love how you phonetically pronounce everything. I think that's really, really good. Like, you're very easy to understand.
Yusuf, now you're making me blush. Like, how am I supposed to respond to that?
You don't. You just don't.
In other news, I believe our speaker has just joined. Hey, Laura.
Sweet.
Laura, if you're talking, we can't hear you.
Maybe it's just Luai. I'm gonna try. Hi, Laura. How are you? Oh, no, not me.
Yeah, she just doesn't want to talk to me. Is that what you're saying?
Yeah, no, that's what I was saying. She doesn't want to talk to you, so I'm gonna give it a try. No.
Okay. 1 second. Let me. Laura, you can message me if you're having a problem. So it's I'm Luai, the person speaking right now. Louai.
Okay, guys, I think we have enough to get started. So, hi everyone, welcome to ISSessions. It's great to see you all here. We have a great meeting for you today, and I'm just first going to start off with a brief rundown of our schedule. The meeting will be kicking off today with some announcements about our future plans. We will then do a news roundup with Adam and Yusuf. We will follow that with a repo rundown with Nick. After that, we'll have Luai present a project den on building detections for mini dump using Sysmon and Procmon. We will then take a short break, conclude with our final segment, which is a presentation by our guest speaker, Laura Harris, on using Bloodhound to attack Active Directory. As always, if you guys have any questions or concerns during any segment, simply unmute your mic or use the questions Discord channel, and we will try to get back to you as fast as possible. However, before we get started on my segment, I would like to take a moment to acknowledge and reflect on recent developments, not just in our province or country, but worldwide with regards to racial inequality and injustice. As president of this club, I feel that it must be known that here at ISSessions, myself, the exec team, and many other members I personally know condemn these acts of injustice. We stand in solidarity with our brothers and sisters of other races, genders, and cultures. It hurts me deeply that things like this can exist in a world while we are so privileged. Being able to go to school and work without being worried about being pulled over, or even going for a jog without being worried about who we might cross paths with, it's very troubling. And at ISSessions, we have a no tolerance policy for any form of transphobic, homophobic, or racially charged statements and abusive comments. So I'd just like to let you all know that no matter who you are, you're accepted here. Doesn't matter your beliefs, your skin color, or your sexual preference. So thank you for listening, and let it be known that Black Lives Matter. Now, with that out of the way, trying to get upbeat. Let's have a great meeting. Okay, so Future of ISSessions. So the rumors are true. We are moving meetings to Thursdays. I would like to thank everyone who gave their feedback on changing the date. The date change means that this will be our last meeting taking place on Friday in the foreseeable future. Now, this isn't to say we won't have events on Fridays, but our regularly scheduled meetings will now take place on Thursdays at 7 p.m. Next item on the list, the CCR, or co-curricular record. We are currently applying for our club to be recognized in the Sheridan CCR. What this means is that any involvement in our community from any of you will get recognition on your transcript. So whether you're a member that just shows up to meetings, or you become a speaker, or you host an event, we will have a process in place to make sure that you are recognized for your contributions. We will have more information on the CCR soon as we get closer to being accepted. Next item, this is a little bit of a bummer, but all meetings and events hosted by ISSessions will be online only for the rest of the year. With our program going online only and talk about a second wave of COVID in the fall, it's easier for us rather, and less stressful if we just plan to not have any in-person or on-campus meetings in the near future. This also means that unfortunately the Sheridan 2020 CTF is being moved to the spring. So if you have any ideas about ISSessions in an online only world, please feel free to post them in the brainstorming channel. We would like to hear your thoughts and feedback on that matter as well. Last thing, we're developing a new website. So with us moving online, it's become apparent that we need a more robust and engaging website. 1 second, sorry. Completely apologize. Okay, so currently, to get a real feel for this community, you either need to come to our events or join the Discord. So our current website serves its purpose for announcements, but there are ways to improve it to better represent this community. So I don't want to make too many promises without having a more concrete product to show you, but what I will say is that our goals for the new website will include, number one, a better website integration with what we do at ISSessions. So that includes meetings, events, and student projects. Number two, we want the website to be just as easy to maintain as WordPress, albeit with more flexibility. So for that purpose, we will be using GitHub pages /Jekyll. And number three, we want to allow anybody to test and contribute their own ideas about the website. So the entire website will be hosted on the ISSessions GitHub repository. Anybody who's able to download and run it offline can do so. And, if they have good ideas, please let us know. We really want to create something that truly represents the talent and quality of this community. So we will have a lot more to show and say about the website in the near future. So we look forward to talking more about that soon. Once again, if you have any ideas about what you'd like to see in a new website, please let us know in the brainstorming channel. That's all for my segment. Up next, we have Adam and newcomer news anchor Yusuf. So please welcome them to give us the scoop on the InfoSec news.
Hi, everyone.
Hey there, guys. I'm Yusuf. If you haven't recognized my voice, this is my voice.
It's beautiful.
Stop, man.
Just give us
Sorry,
1 second while we switch over. So yeah, and we'll get started. Okay, so sorry about that. Yeah, so for the first news stories, Huawei has denied involvement in a buggy Linux kernel patch proposal. So one of Huawei's top security engineers created a pull request to the Linux kernel with a new module called Huawei kernel self-protection. And because it had the word Huawei in it, it got a lot of attention, and so researchers started pulling at the pull request and realized that there was a lot of trivially exploitable vulnerabilities in the code. Since that time, Huawei quickly responded, stating that the employee in question acted independently, and kind of the employee put in some disclaimers saying that this is more of a passion project of his, and just clarified that. So, yeah.
So next we have Clearview. The Clearview AI agrees to delete facial images from biometric services, but they excluded Canada from this. So if you know or don't know, Clearview AI has been going around for the past little while, and it's going around online tracking people's faces. So they have headshots of a lot of people, whether that be Canada, States, any other country, and they're keeping track of them. So they have a system, an opt-out system, where you are allowed to opt out and delete those records of your face in many countries. However, that's not happening for Canada. They claim that their AI is only being developed for law enforcement use, but a bunch of people, nonprofits, and tech groups fear that this will be used for mass surveillance without people's consent. And so as a result of that, the Canada's Privacy Commissioner and a couple of provinces launched their own investigation to decide if the AI is violating federal or provincial data protection laws. You can even go on the website, the Clearview website, and send an email and see what records they have of you, if any. If you want to go look at that, just check out the article. You'll see that email. And then lastly, the Ontario Commissioner said that at least 15 provinces in Ontario have used this Clearview AI for their cases and their day-to-day law enforcement.
So there is a print daemon vulnerability that impacts pretty much all Windows versions. So two security researchers discovered this vulnerability in the Windows print service. It affects all versions of Windows, going back to Windows NT 4. So that's 1996. So like many years back. This is a local privilege escalation vulnerability. So as long as you're able to log into the system, because all users have access to the print service, they can exploit the bug. And what it allows them to do is write to the operating system using system level permissions. So using that, they're able to write and escalate their privileges through that way. There's exploit code available on GitHub. So yep. And then Microsoft released a patch for this and disclosed it. And then it turns out that the patch broke a bunch of print services. So, yep.
So I know a bunch of us use the Adobe Suite. In the past week, Adobe released a patch that included 18 critical flaws in out-of-band updates. This was a result of the huge Microsoft update that they released, probably the largest one in history. And so they released the 18 critical flaws and out-of-band updates. The products that these patches are for include Adobe After Effects, Illustrator, Premiere Pro, Premiere Rush, and Audition. The vulnerabilities would allow attackers to execute arbitrary code if the bugs are actually exploited. However, Adobe is not yet aware of any attempts to exploit these bugs, so there really isn't a huge worry on that. However, they are strongly recommending that everybody who uses the Adobe Suite go through with this update. The After Effects flaws include, just because I use Adobe After Effects, it includes out-of-bounds read vulnerabilities, out-of-bounds write vulnerabilities, and heap overflow flaws. So again, if you use the Adobe Suite, I think it's time you update it if you have not yet.
And it's quite timely since, like I said, some people are returning to the office. So, yeah, we'll see how stable they are. So for the next one, So this is kind of interesting. So there's the operators of Ragnar Locker have been found to be using virtual machine to run their malware, and through running their malware in a virtual box in a virtual machine, they're able to bypass the antivirus program on the host machine. So the way this works is the group installs VirtualBox on the target computer, and then they download an XP, a lightweight lightweight XP virtual machine with the malware on it, and they configure it to allow it to write to the host disk, and then through there they're able to encrypt the hard drive of the user. This is kind of this is interesting because it's been kind of theoretical. This attack has been kind of theoretical, but this is kind of like the first kind of example of it being used in the wild. The group itself, they don't mainly target consumers. They mainly are highly targeted corporate and government organizations. So yeah, kind of interesting evasive technique.
So this one's, I would say, kind of funny, but not really. So in 2017, the CIA had their one of their biggest breaches biggest breaches, I guess, in history. The Vault 7 disclosures that led to at least 180 gigabytes to 32 terabytes worth of leaks. So now a U.S. senator is demanding to understand why the agency hasn't yet followed guidelines set by the state. And most U.S. agencies, other security agencies and whatnot, have a bunch of these guidelines in place and are practiced. The funny thing about this is the CIA still to date doesn't have even simple measures like domain-based message authentication in place, nor do they have something like multi-factor authentication for the CIA's .gov domains. So this is like, I guess, like kind of, what's the word for it? It goes against everything that we're learning in school and everything that we practice. I feel like a lot of us have multi-factor authentication on most of our email, social media accounts. So having something like the CIA not practice this is very offensive to our community, I'd say. And the report says that they've been prioritizing building cyber weapons, but not protecting their own systems, which is, I guess, just another whammy on top of the entire story.
It seems to be like a common, it's a common problem even in the corporate side is we want to build, but we, defense 100%. Is kind of, it's like the push to constantly build, constantly move forward, but you need to cover your bases.
100%.
Yeah, for sure. So for this next one, so this is an article about a research report that was published about the regular life of cyber criminals. So it drew some interesting parallels. I'm not sure, like for me, for example, and even in the article they mentioned, we kind of have an idea that cyber criminals, they kind of are able to do like a lot. They have a lot of freedom, and we keep hearing about them doing crazy stuff regarding breaches. But it turns out that that's a very different perspective. That's not what reality is. So cyber criminals that try to sell their services, they're constantly like monitoring their reputation, answering support questions, and doing like administrative work, which is so kind of tedious stuff. And it's kind of it also doesn't quite require strong technical skills. It's constantly just rebuilding. Once defenders knock down your infrastructure, you're just constantly rebuilding. And also they mentioned about money, that it's similar to like a traditional crime networks, that where the majority of the people kind of at the bottom don't make a lot of money, but the people at the top might. So yeah, kind of interesting. So yeah.
So we've heard, or I've heard it, I feel like we've all heard about Zoom a lot in the news lately, just from their weak security for meetings and allowing anybody to almost join them if they have the link. So there's this new, so a couple days ago, actually, Zoom said before this statement that they weren't going to give end-to-end encryption for non-premium subscribers. This past Wednesday, they went back on that statement and said they would. This was a result of a bunch of nonprofits, tech groups, and thousands of users asking Zoom to rethink their decision. In Zoom's defense, and I quote the CEO, "Free users, for sure, we don't want to give end-to-end encryption because we also want to work with the FBI, with local law enforcement. In some case, people use Zoom for a bad purpose." So with that said, it's kind of, they're targeting that business aspect. They're not really targeting. They're not trying to make Zoom a social media platform. However, that is a part of what they've become. And so it's kind of in like the opinion of users and whatnot, I feel like it's like saying having Google or Facebook saying they're going to charge you for the better security. So I think it's cool that the power of a bunch of people pushing one big organization to make changes actually did do something for once. So yeah, just something to think about when you're using Zoom, if you're using it.
For sure. I think they kind of pushed themselves into this kind of rough corner where people kind of through COVID, they were like, oh, let's use Zoom calls and everything. They didn't really, they kind of were like quietly didn't say, no, we're like a business
We don't want you
solution,
guys.
right?
Yeah, we don't want you
So,
guys.
yeah. But it's hard to take something away once it was available. So
No, 100%.
Yeah, kind of a rock and a hard place.
Yeah, okay, Adam, couldn't hear you.
Sorry.
It's all
Yeah,
good.
I had some issue. Yeah, so for Intel's new mobile CPUs, codenamed Tiger Lake, so they're going to be implementing a new feature called control flow enforcement. So the idea is this control flow enforcement is supposed to mitigate against the modification of instructions into running arbitrary code. So basically mitigating, as we call, buffer overflows and use after free vulnerabilities. And they go about this in two different ways. They have indirect branch tracking and shadow stack. With indirect branch tracking, so basically, whenever programs when we program, we'll, for example, have a reusable part and we'll jump to it. For example, for like if statements or for method calls, you'll jump to memory instructions. And so if people, for example, modify that address or that instruction using a buffer overflow or those types of things, they're able to execute arbitrary code. So that's one of the ways that they're doing. So with indirect branch tracking, they're adding a new instruction called end branch, which is supposed to track those indirect calls and jumps to detect violations. So if the program's not supposed to jump to a particular memory address, it would be able to pick up on those. And then with shadow stack, this is basically when it deals with the return. So when you buffer overflow the return address, you can have the program jump to a different place in memory to execute, for example, your own instructions, or for example, like get a shell. So what it does is it creates a shadow stack, so a secondary stack that monitors and compares the two memory addresses of any return memory address, and compares the two to see if they match. If they do match, then it means that the memory address hasn't been corrupted. So it'll be quite interesting to see this technology actually being implemented. They spoke about this in 2016, and so now we're seeing it being implemented. But with modern programming languages, buffer overflows, in your programming languages, buffer overflows are becoming quite rare, just because of all like the levels of abstraction that we have. But with, for example, older programming languages like C is notorious for having buffer overflow, and a lot of operating systems are still relying on those types of languages. We'll see how that will probably benefit those types of software.
So with this one, it's interesting. I don't know if anyone's followed Intel in the past couple of years. You've probably heard about the Meltdown Inspector vulnerabilities that the Intel processors and their memory have. So when those vulnerabilities came to light, Meltdown Inspector, they released this thing called Software Guard Extension, SGX. So the purpose of this security measure was to protect the passwords, encryptions, and more from the silicone resident memory, as the article said. And the main purpose of this was to actually defend these things in a situation where something like a Meltdown or Spectre attack would happen. Now, with that being said, it's kind of a new, as a result of this SGX, a new vulnerability came on top of the two that it was supposed to fix. The two attacks that are caused by the SGX are known as SGAXC and crosstalk. And essentially what they are is they're exploded by measuring the time differences, power consumption, and electromagnetic radiation, sound, and more. So it's using a bunch of things that our computers hold to be able to access the very, I guess you could say, weak security around the memory. And so in a situation where you have a Meltdown or a Spectre attack happening, the SGX is supposed to protect from that. However, a new vulnerability has come. So it's a bunch of layers with vulnerabilities. So it does still make it fairly difficult, but it's something to think about with Intel processors.
Okay. So Apple, so there a bug hunter discovered that there was a flaw in Apple's implementation of sign in with Apple. So sign in with Apple, similar to, for example, Google sign in or Facebook sign in, it uses OAuth, where basically Apple is your account resides within Apple services, and then you the application just kind of, whenever you want to log in, the application redirects you to Apple servers to get authenticated, and then you come back to the service with the token saying like, I'm authenticated, here's who I am, verified by Apple. So basically the researcher was able to trick Apple's Federation service to validate their GWT token for any valid account. So basically, if there was an email address that was registered with if there was an Apple ID registered with that email, then they were able to get Apple to validate it. And so when they would present it to a site, the site would allow them to sign in with that account. So the researcher responsibly disclosed it, and Apple has since patched it. And they gave the researcher $100,000 for the bug bounty. So there was a good write-up actually by this bug hunter. That is an interesting read for sure. Okay, and then for this, so GitHub has issued a security alert about a new rat, so a remote access Trojan that has been spread by burrowing into Java repositories on the site. They identified 26 public Java repositories that contained the malware, but they did not disclose which open source projects those were. The malware, so basically how it worked was once a developer would download that open source Java repository and compiled the code, the malware would execute on the developer's workstation and would search for the presence of Apache NetBeans IDE. If found, the installed rat would allow the remote attackers to remote into the device to search around to see what sensitive code or what the developer was working on. And also, a feature of this rat was that it would bury itself within the IDE, and any project that developer worked on, it would push up that malware to the repository, so it would spread throughout the organization through this way. It's suspected that this may be like a targeted attack for something, but Java is a mainly enterprise programming language, and so they probably got some interesting stuff if they did manage to get remote access to a developer works.
If I could just add on to that, Adam.
For sure.
Apparently, they were saying how in a different article that I read on this, how they called it an octopus scanner because of just how fast and easily and widespread it could spread. And apparently, it's been floating around since 2008. And what's interesting is you can't just simply block out the file that contains or the project that contains that malware just because a project has many dependencies that rely on certain files. So it can't just be blocked. So it makes the labor very intensive on the developer's part.
Oh, for sure. And for like big development shops,
Yeah.
you know, you have different repositories, like scanning the whole, like different repositories, or if they modify it slightly, like it's
Yeah,
going to be around for, you know, it's going to
100%.
be hard to eradicate.
No, for sure.
GitHub allows for scanning, but, you know, a lot of enterprises also have their own on-premise repositories. So that may be a good way to spread. And developers push up code like, you know,
All the
daily
time.
to the
Yeah.
repository. Yeah. So it would spread really fast.
No doubt.
Yeah. So this is just a quick announcement. So Windows announced that they'll be including that they're working on a Windows package manager. So you can see in the screenshot here, you can basically download your code. So they're a bit late to the party. Linux has had this for a couple of years now, but you know what? I'm really excited for this project. So yeah, we'll see how it turns out. And then that's everything. I hand it off to Luai.
Well, we got Nick next. So.
Oh, I'm sorry, Nick.
No problem. Great job, guys. You know, huge thanks to both Adam and Yusuf for their news roundup. We do have Nick's Reaper Rundown up next. Unfortunately, Nick was not able to be here for this meeting, but he was gracious enough to pre-record a Reaper Rundown segment for us. So with that, I'll leave you with Nick's Reaper Rundown.
So this is the Rick's Repo Rundown for ISSessions on May the 19th of 2020. I can't be there this week, so I'm pre-recording this. This week's repo is a project called ReconPy, which is basically like a big bash script that installs a ton of reconnaissance tools onto a Raspberry Pi. The idea is that you supply it with a domain name, and it will scan that domain with a bunch of different tools and provide you with some reports and output, hopefully to use as sort of like a precursor to a penetration test. Tools here at the link on GitHub, and the author was X1MDev, or I don't know, ZimDev. I'm not totally sure how you're supposed to say that. So the author's description: a lightweight recon tool that provides extensive reconnaissance with the latest tools using a Raspberry Pi. And I mean, the joke about people having lots of Raspberry Pis sitting in a desk somewhere, and that this is, you know, something that you can actually use your Raspberry Pi for, which is great. And it also says version 2.1 is now usable on your VPS, which is great because you could just deploy this onto a server and hopefully, you know, run it from there instead of just off of a Pi, which is super useful. Installation is pretty easy. Just connect to whatever the host is, and basically the GitHub repo hosts an install script that you can pipe right into Bash if you want. You know, you should probably just have a quick scan over it and make sure that it hasn't been patched maliciously before you pipe the install right through Bash. You don't actually need to like clone the repo. The install script actually takes care of grabbing what it needs out of the GitHub repo for you. But basically, my sort of rundown of it is that it's one giant bash script that throws a bunch of tools against a domain and generates you some reports. So the usage is pretty straightforward. You just type recon.sh and then you point it at some domain, right? So like, you know, facebook.com or whatever. The idea is it runs a bunch of what they call, or it gathers a bunch of resolvers to give you access to a bunch of like DNS data. It tries to do subdomain enumeration, so like www.the-domain you specified, mail.the-domain you specified, dev.the-domain you gave. So it does a bunch of brute forcing and use lists to build a list of potential subdomains. Also gives you lists of ones that maybe you could take over, so like a domain that's there, but there's like no registered domain name for. Maybe you can go register it to hijack it. It'll try to find IPs associated with that and then enumerate them and port scan them. It will also try to visit any web-based targets that it finds on those domains and subdomains and sort of use the automated browser screenshot taking to build a collection of data that way that you could maybe use for, determining the endpoints and web application vulnerabilities, things like that. When the scan is finished, you run this Python line. Python comes with like a project that's like a built-in HTTP server, and you basically turn this thing on, and it will show you where to get the results for your scan. You can also configure this thing to throw a message into a Slack channel when it's done scanning, because if you enable all of the functions in this, some of the scans can be quite time-consuming. It installs a lot of tools. This is the list off of the GitHub page of stuff it installs. If you start looking through this list, again, you'll see a lot of stuff for subdomain enumeration, things for accessing, websites on domains, scanning the websites themselves, looking for various assets like JavaScript files, tools to then parse those JavaScript files for links to other resources on the same site. There's port scanners like MassScan and Nmap. There's the wrapper for Shodan in Python. It pulls down word lists from sec lists to use for brute forcing. Like there's fuzzers, there's like a vuln scanner. It loads up a huge collection of tools, and what's interesting is a lot of these are actually written in Go, so they're pretty fast. Especially stuff like GoBuster, which is like the Go implementation of a tool like dirbuster for finding, file paths on web servers and in web applications. So basically, it calls these functions. The big script calls these functions in this order. So gather resolvers, so like DNS resolvers. Gather subdomains, meaning find all the subdomains associated with this domain. Check takeovers, which is looking at the subdomains to see if any are vulnerable to a takeover or if they have been taken over. Get CNAME records for the domain, so other like aliases basically. Gather IPs associated with the domain. Gather screenshots of stuff you can navigate to. Start Meg, which was, sorry, I forget. Meg was a distributed dirbusting tool, right? So start doing dirbusting, fetching more of the data from the application and the results of some of the previously run tools. Fetch the endpoints was looking for things like API endpoints that the websites might have that this thing is hosting. Run nuclei, which is kind of like a vuln scanner. It makes more sense if you read through the project, but you can specify like templates to allow this thing to capture more detailed information from endpoints and sites. And then it runs that Shodan check, the port scan, and then it dumps the notification into Slack if you've configured that. So the way this thing is organized, so the repo itself is really simple. There's one folder with a word list text file in it. That's just a big word list that can be used for brute forcing. And then there's 3 actual files outside of the standard GitHub stuff. There's install.sh, which is the installation script. There's recon.sh, which is the actual program itself. And there's tokens.txt, which is kind of like a config file. So for example, if you do want this thing to dump a notification into your Slack channel, you have to put like your Slack key into this tokens.txt file, which is parsed by the recon.sh script, along with some of the other tools that might need a key. Basically just won't run stuff if you don't supply the keys for some of those services. So the way it works, if you run install.sh, first off, it prints a logo. We all love ASCII art logos, and it's essentially lots of what you see on the right-hand side of the screen here. So like, Git cloning repos, doing apt install for prereqs. A lot of these tools are either Go or Python, so running like pip install, or Go's package manager, which is like go get and then some package name. And it just adds it all somewhere in the root of your home directory. Restart services if required for containerized applications and stuff like that. A couple of more specific tool installation examples. So on the left is installing Rob Graham's MassScan tool, which is like a really, really fast port scanner. And so it just grabs it from GitHub and then makes it, and that's kind of it, along with the dependencies. It's neat the way they use MassScan here. So they mass scan the target first to find out which ports are maybe available, and then runs Nmap on only the ports that MassScan reports are as being open. So you're not like using a ton of time with Nmap. You're basically doing the MassScan first and feeding the results of that to Nmap, which is kind of cool. And then on the right is an example of it installing Shodanify using like pip and cloning the GitHub repo and stuff like that. The main actual recon.sh bash script, and the reason I wanted to do a bash script this time instead of Python program is that one, I don't know, just haven't done bash in a while, and two, this one's got some good examples of how to do a lot of like batch installation and batch running of tools in a giant script. There's some good practices in here that someone could follow. So initially it sets a bunch of variables. So these ones here are actually used for like resetting the terminal and coloring terminal output, which is always really handy because some of these things can be annoying to write into scripts. So having them in variables is really easy. And then the rest of the variables are essentially directory locations where results will be stored for the various applications that are installed. Then the application just checks to see if you provided it with a command line argument, which needs to be the domain that you want to scan. And if you didn't do that, then it just spits out a warning message. This is kind of how you, you can check to see if there's args. And then there's just a bunch of function names similar to the order of operations that I listed here. There's basically a function name for each of these that in turn calls all of the individual tools to gather the data for you. So gather resolvers prints a little message that says, hey, we're starting the gathering resolvers phase, and it'll run this tool, BAS or base, I'm not sure how you're supposed to say it, and grabs any of the data and dumps it in IP/resolvers.txt as an example. And lots of the tools are essentially run like this, as a little function with some kind of logging detail, stuff to note like cd into home/tool/base or return, which is kind of interesting in terms of how we're structuring this giant batch script. So here is how they're kind of automating printing out messages and resetting the color on the terminal. So basically it'll say in green text, it'll say done, then next, and then it will run the next command. So again, just more examples of how it is batch running the commands here, which is really useful because I think it's installing the commands into this subdirectory in your local folder, and then it's executing it out of there and dumping the results into some location. So that one was subdomain finder and asset finder, which finds like other assets on a list of URLs. Gather IPs, so this is where it's checking against the subdomains and getting the IP addresses associated with those and dumping them out for you. Here's the port scan. So as you can see, it grabs the IP list that it generated in the previous step, and then is feeding that into masscan. And masscan will dump the reports into a file called ports, I think. Or it dumps it into a result called masscan, and we parse that apart and get all the ports. And then just the ports with the IP address are fed to Nmap for more detailed scanning results on those ports. So that's kind of how the port scanning works, which is neat inside of a big bash for loop. Here's running a tool called Aquatone, which is automating the taking of screenshots from the various hosts that all of these subdomain and IP scanning found. So it basically simulates, navigating to that page in a web browser and taking a screenshot, and then dumping that into a directory for you. Fetching endpoints. We'll run this link finder thing, which parses through like JavaScript files, for example, and it tries to see if JavaScript is making calls out to any API endpoints, because those would then be associated with the web application, and it stores those in a text file called endpoints as well for later searching and analysis. Here's it running, for example, some of the directory brute forcing with GoBuster. This is a wild command line, so it's taking all the hosts that you found and then running GNU parallel. I think that means like 5 cores, and giving you a status bar, and then running GoBuster. So like running like 5 instances of this, or running GoBuster in parallel with the word list that is located in the repo, and then dumping all the results to sub.txt. So it's basically going to try to find all the file paths in that web application or on that host that you found. When it's done running like that huge collection of tools, and I've only provided like a sample set of them here, but when it's done running that, then one of the last things it does is run this make page function, which basically, one of the previous steps was to install the Nginx web browser on your device, whether it be like a VPS or your Raspberry Pi. And then it starts to build a simple HTML page of all the results. Like it dumps all the screenshots into a location, and it basically gives you links to those on the web page. And then it kind of tells you where to find all the results for your scans and stuff like that. And then the last thing it does before quitting, if you've configured it, is to dump a notification into your pre-configured Slack channel, which it does right here because Slack's got an API, so it just makes post requests into Slack saying, hey, ReconPy is finished. Here's where you find this info. Here's where you find this info. Here's where you find this info, and so on, which is kind of cool because obviously some of those operations like the nmaps and all the, go busting will take a long time. Who knows? It could take upwards of a day or two. So you want to be notified when this thing's finished without maybe having to check back at the VPS every so often or at regular intervals. And that's really the repo this time. I like it as an example of a really clean, modular, well-organized, gigantic batch process where a whole ton of tools get installed and configured for you, and then are all executed in a really logical way using the output of previous tools to inform later tools, and really automating a lot of tedious manual domain research that you would probably have to do before starting a pen test. I think it's really great. And that's this week's repo. Hope you enjoyed it. Thanks.
Once again, awesome rundown. Huge shout out to Nick for taking time out of his day to pre-record that. I believe ISSessions is never the same without Nick, so I do appreciate his commitment. For our next segment, we heard about this threat hunting intern working at Bell named Luai. There are rumors that he has information on building detections for Minidump. And although these rumors are unsubstantiated, we decided to give him 30 minutes on ISSessions anyway. So
Wow.
Wait, Kurt, who is that? I've never heard of him before.
Oh my god.
So without further ado, former president Luai and his project Den, building detections for Minidump using Sysmon and Procmon.
Okay, hey everyone. So thank you first of all for the awesome introduction.
Of course.
So I'm going to share my screen now. So if you want, you can just switch from MadSprite's share to my share, if you don't mind.
Or you can stay on MadSprites. You can do both.
Oh, okay. Are we doing it that way? Cool.
It shouldn't matter. Yeah, if they want to switch to you, it's okay. But they can. MadSprite should restream yours as well.
Sounds good. So just give me 1 second. Okay, so in what is the most corporate line of 2020? Can everyone see my screen?
Yep.
Okay, sounds good. Okay, Kurt, do I have your permission to get started?
Go for it.
Cool. Okay, so welcome everyone. Thank you so much for coming to this ISSessions. So today I'll be talking about detecting process dumping, more specifically a technique called Minidump, using Sysmon and Procmon. First of all, hopefully you know who I am by now, but just a quick kind of rundown for those who don't know me. My name is Louis Aboud. I'm a Syrian Canadian. I'm currently doing a threat hunting internship at Bell. I do see right now that there are a couple of my colleagues at Bell who are watching the presentation, so thank you so much for the support, guys. And I am a former president of ISSessions and also the current vice president. Sorry, 1 sec. Sorry, can everyone hear me? Okay, give me 1 second. I'm having a problem with the sound.
Oh, it's because you're still in MadSprite stream, so you should leave that.
Can be in 2 streams at the same time. Interesting. Better?
Yep.
Camera here? Okay, cool. Okay, sorry about that. So let me just continue. So yeah, so here actually some pictures, just so you know, you see how I look like. This is actually us working on the CTF last year. I have no idea what Kiefer's doing over there, or what Owen is doing with his hands like that. It was a fun time, and it's one of the many great events that we host. I also wanted to point out that this club does a whole bunch of events that are non-infosec. We had like a great bowling kind of extravaganza with Seneca last year. That was really fun. And we hope to do stuff like that moving forward. You can see there, Kiefer's like really happy. I think there's 4, like he had 4 beers. He's got that crazy wild look on his eye. You can see Jem over there, who looks like Simba after he became the Lion King. We do a lot of stuff, and one of the things that we do is this segment. And so I want to just talk a little bit about my motivation for doing this talk. The first thing is that I wanted to present a practical example of the threat hunting process. I think that we do a ton of talks here about like blue teaming and sort of like we give a sort of like overarching process view, but we've never actually dug deep into creating rules, going through a hunt, analyzing a vulnerability or analyzing a technique. So that was something that I wanted to bring to the table. The other thing as well is that that this is a Linux heavy program. We don't really focus a lot on Windows, and so I wanted to start introducing a few more Windows concepts, because that's really important in industry, as many of the alumni and the people doing co-op are probably realizing that right now. 3, I wanted to kind of demystify some of the misconceptions about SOC environments, and SOC, that's Security Operations Center environments. A lot of people seem to think that's just like like the tier 1 analyst, tier 2 analyst, and they're working 12 hours a day. But SOCs are actually like very dynamic places, and there are many teams working together to protect the organization. So for example, at Bell, we have teams, threat hunting teams, which actually create content, create rules, and do a lot of research. But then we also have teams that develop software for the SOC. We also have teams who actually work on tuning Elasticsearch, or tuning a whole bunch of like products. We have a ton of open source products that we use, and they take care of putting that into the environment and making sure all of that is working. So there's a ton of stuff happening there, and I would say that the tier 1, tier 2 analyst stuff is only maybe like 20% of what happens in a SOC. And so I wanted to kind of show you the other side of the things that was happening, and hopefully in an interesting way. And then the fourth objective was a personal objective. So I want to solidify my learnings by sharing with others. And really that is the goal of this segment. So I introduced the segment last year because I wanted students like myself to stand up and to talk about little projects that they've worked on, because I think, I truly think that the most kind of learning happens when you go through down that rabbit hole, and you try as much as possible to kind of go off of what school is teaching you, but try to explore paths that nobody else has explored. And really that's what projects are all about. So I encourage you, please, after watching this presentation today, please do come and do your own. I know the new team would really appreciate as many speakers as they want. And I would also appreciate that, because I'm still a member of the new team. A few things just before I get started. So if you don't understand something, I know there's going to be like a lot of new stuff. Please just carry on. The more you hear it, it'll come eventually once you've watched the second and third and fourth presentation. If you can, if you want, you don't have to, of course, you can take notes. Feel free to ask questions. You all should have the ability to kind of unmute yourselves and just interrupt me and ask a question. I have no problem. You can criticize me. I don't care. I'm a student. I'm still learning, and I would love to learn with you. And finally, as I said again, please come up here and speak. So before I actually dig into the actual technique, I do have to spend just a little bit of time on the actual threat hunting process, just so we kind of have a framework to work in. So the most important thing that you want to do when you are approaching a hunt, right? When you have a threat that you want to build a detection for, the first thing you want to do when you choose that technique is that you want to do a lot of research. And the research can be split into three parts. One is that you want to understand your environment. Two is that you want to research the technique as much as possible in as much detail as possible to understand the history of the technique. And three is that you want to establish what is benign behavior and what is malicious behavior. And the reason you need to spend so much time on research, and why we'll be spending so much time on research today, is because of something called analyst fatigue. So essentially, imagine that you are in a position where you have to, detect when somebody edits the bash RC file for persistence on Linux. So the bash RC file, an attacker can inject code into it, and every time you log in, that code would run. And so that can be a persistence avenue. Well, if you're going to write a rule that says, okay, well, I'm going to create an alert that my analyst now has to respond to. So now we've gone into incident response. But you have no idea how much the bash RC file is being edited in your environment, then you're going to end up creating, maybe if that bash RC file is edited by sysadmins all the time, you're going to be creating a ton of alerts. And guess what's going to happen when that alert keeps triggering again and again and again for that analyst, right? And every time it ends up being like a false positive, and it's not something that is malicious. So they're going to start kind of ignoring that alert. And then when something real happens, you're not going to catch it. So it's very, very important that you understand your environment. How are things being used? What is the user behavior, right? What is happening in dev versus prod? What OSs am I running? And then you want to research the technique, understand the history of the technique before you write the rule. So kind of obvious, but you'd be surprised how often it's missed. The second thing, from the research, you want to establish some hypothesis or hypotheses. So you want to say, for example, for process dumping, well, I can do a process dump in this way, in way A, way B, way C. The way that I recommend that you approach this is that you want to separate the way that a sysadmin would do it in your environment from the way that the hacker would do it. The challenge here is that there's always kind of something in between. And obviously, the more sophisticated attackers are going to emulate the sysadmin way as much as possible so as to avoid your detections. So things can get very hard when you're dealing with a very sophisticated attacker. But you need to go through this exercise, because when you're looking at everything later on, you can quickly point out, okay, what doesn't look normal? What is malicious behavior versus what is not malicious behavior? And then when you have those hypotheses, you want to get proof of concepts for them. And a proof of concept is just like a little piece of code that demonstrates the attack. You want to create those POCs. You want to run them in like a test lab or some sort of environment. And then you want to collect data based on how those run. What kind of data can you collect? Well, there's like logs. So today we're going to be looking specifically at Sysmon logs, because that's the kind of the most well known in like a Windows environment. So it should be fairly easy to understand. It's very well organized. You can do static and dynamic analysis. This might not be something you can like alert on, like a log is, but it's something that can help you understand what you are seeing in the logs. You can look at things like network traffic, and then there's a whole bunch of other stuff like ETW, for example, like event tracing for Windows. And a whole bunch of other sources. And then finally, once you've run those POCs and you've collected your data, you want to build a detection. So you want to now write a rule. And what does a rule look like? Well, you can write like a snort rule, you can write a Yara rule. If you have like Elasticsearch or Splunk in your environment, you would essentially write, which are kind of like log ingesting machines or clusters. You can write rules to search on those as well. Then you want to test the rule. So there's typically like a period where the rule is in testing, where it's going to trigger, but it's not going to send an alert to the analyst. And you want to assess, the false positive rate of that. And then finally, you want to tune the rule based on what you see, and you want to put that rule in production. So hopefully that gave you a good idea of the threat hunting process. I'm sorry for spending so long on process. Let's actually go on a hunt. And so before we actually even start the threat hunting process, we obviously have to know, what are we hunting for? And where do you find this information? Where do you get ideas? Well, there's a whole bunch of kind of different places that you can get hunt information from. And they're called like threat intelligence feeds. So, the Department of Homeland Security has one. The Sandstorm Center has one. There's something called Cisco Talos. In Europe, there's something called like the Spam House Project. But sometimes all it takes is a good tweet. And the person in this tweet, his name is Samir Busadin. He's really big in the threat hunting space. And he tweets sort of like new techniques all the time. And when I first started kind of like this project, it started by me seeing this tweet. And what you see here is a Sysmon log. It's event 1. And you can see the command line for that log. So this is what was actually executed. So imagine yourself actually typing on the command line. Was run DLL32. It's calling some DLL, which is like a library, comm services. And it's invoking something called the mini dump function. Okay, and then there's a whole bunch of parameters that are actually being passed to that function. Okay, so I'll come back to this later, but the idea is this is kind of where it was the initial starting point of the project. So what is process dumping? Process dumping is really producing a memory dump of a process and then writing that dump to disk. So if you think about what a process has in memory, there's like the actual code that's running. There's the stack, there's the heap, and the stack has, your local parameter, your function parameters and your local variables and that kind of stuff. And sometimes there's valuable information for an attacker inside of a process's memory. And so essentially what you're doing is you're taking a copy of that memory and you're dumping it to disk. And there are multiple types of process dumps. So there's a full dump, which effectively gives you all memory. There's a mini dump, which gives you just certain information about the process or where like a certain crash happened. And there are tools typically that sysadmins use to use this. So actually not many people know that Task Manager, in fact, allows you to create a process dump. There's also a sysinternals utility called process dump that allows you to dump the memory of a running process. So imagine that we have, Kurt, your beloved president. He's a sysadmin. And then we have Jem, who's our community manager. And Jem, said, I hate security. I'm just going to become a developer. Right. And so what would the developer and the sysadmin use process dumping for? And the idea is a long time ago, and still a little bit now, you see process dumping being used to debug the cause of a fatal crash. So I want you to remember, in this program, your first year, you learn C, and you have just segfaulted. Well, you can actually configure Linux to create a core dump every time that a segfault happens, and then you can go and actually analyze that segfault to understand. The core dump to analyze why that segfault happened. What can you see in a core dump? So the whole memory image, some of the contents of the registers of the CPU, and then memory management information, like what address did the segfault happen. But of course, as is often the case with things like with these techniques, the legitimate case ends up getting abused to give us the illegitimate case. So now we have Nishad, who's our treasurer, and Nishad is a bad hacker, right? He's gone to the dark side. Nick didn't teach him well, and he now wants to do a few things by creating that process dump. And a process dump will contain, depending on the process that you're dumping, of course, will contain maybe passwords, maybe SSH keys, maybe API keys. So there's a process in Windows called LSAS, which is the Local Security Authority Subsystem. And LSAS, for many reasons, caches credentials in memory. So you can actually create a dump of that, and you can actually view all of the people that have logged onto a Windows machine. And of course, you can use that information to laterally move across the environment. You can maybe not, I'm not sure if many of you have heard of like SSH agent. You don't really need to use it, but some people do. So SSH agent will cache your SSH keys in memory. So you can also dump SSH keys, or think about really any agent running on a machine. So let's say you have like a packet beat agent, and it has the API key, or sorry, not the API key, but just like the secret key to connect with like a logging cluster, for example. Well, if you dump that process, if it caches that key in memory, well, you can actually go ahead and retrieve it, and now you know how to connect to that cluster as well. So that's kind of the use case for an attacker for process dumping. So again, that's process dumping in general. What we're going to be focusing on is something called mini dump. And mini dump is a very specific process dumping technique. So let's read this for the first time. And when I first read this, I had no idea what any of this meant. But then I dug in a little bit deeper, and I found out. So it's a technique for dumping process memory by invoking run DLL32 on the mini dump function in the COM services DLL. So I was like, what is run DLL32? What is mini dump? And what in the world is the COM services DLL? Remember, I've only kind of been working in threat hunting. I'm an intern, right, for about a month. And I was listening, I was hearing this stuff at work, but when I was doing this project by myself, I didn't really I still didn't know kind of all of this stuff. But then what I did was I went down the rabbit hole. And this is, again, the research part. This is what you have to do. And so down the rabbit hole we go. So I knew that I needed to understand something about COM services. And when I went to visit COM, I saw a whole bunch of stuff about the Win32 API. So let's talk about what the Win32 API is. So the Win32 API essentially allows user mode programs to interact with and then request services from the Windows kernel. So you've got like a set of functions. There are about, I think, 250 plus functions. They're all written in C. And underneath those functions, we have things called the native API calls. So these are functions that sit beneath the Win32 API. They're not documented. The Win32 API is, of course, documented because it's an API that developers have to use to develop applications on a Windows system. How can you use the Win32 API? It's actually very easy. So in a C program, you can just include windows.h. And then you can start calling certain functions. So for example, they're quite intuitive. So to create a file, you guessed it, creates a file. Create process, creates a process. Load library, loads a library, and then you can get a function in that library. And then here we see that there's the mini dump write dump function. And this is going to become important later on because this is the function that every process has to go through in order to create a memory dump on a Windows system. Actually, that's not exactly true, but 85% of dumps are created this way. Most of the big tools use this. The thing about the functions here. So for example, create file is a lot like fopen, for example. But this is just in Linux, fopen in Linux. So, but create file is kind of like the Windows implementation. This doesn't mean that create file, implements fopen underneath somehow. It doesn't. So this is related to some CPU subroutine which gets called, and it's only relevant to a Windows system. So now you know what the Win32 API is. Well, it turned out that there was actually quite a few problems with this API. So one is that there was no logical grouping. Windows was just like, here are 250 functions for you to use. There was you had to go through a lot of repetition to do some very basic things. So like, for example, if you needed to create a window, for example, you needed to rewrite that code again and again and again. And of course, as we know now, where we use high-level languages, we don't want to do that, right? We want to simplify the process of software development as much as possible, and we want to focus on business logic. And then the final problem was that the only way to access OS services was to write code in C and C++, right? And typically you don't want to do that, right? Because those don't have garbage collection. They are hard languages to learn, etc. You've all programmed in C. You should all know how hard C can be, and that's why we use high-level languages now, which abstract a lot of things for us. So then what happened is that they actually created something called the component object model, which is COM. And the idea for COM is to create a black box that was accessible by different applications and by different programming languages. So think about, the fact that you have like a program that needs to import a library. But typically when you import a library right now, so think about like Python code, you just write import something. Well, the idea here was to try and create a system whereby any language can actually get this library. And the thing about that was that program did not need to know about the underlying implementation of that library. It basically just calls a function and then gets an interface, and from that interface it gets a method, and then it will go ahead and start using that method. And this can be done from any language, and this actually was kind of genius. And so if we think about, how do we actually accomplish this, right? So certain conditions had to be met. And so they had two foundational principles. One is that they created something called, COM had to be a language agnostic binary standard. So essentially, what they did was they imposed a structure on the COM code. So you have basically a whole bunch of methods, and those methods are grouped into COM interfaces. Those COM interfaces are grouped into COM classes, and then those COM classes are implemented in a DLL, which is the library that we want to import. So why did this have to be binary? Because, well, if I now import C code into my Python code, I would have to have a compiler that can actually compile both. So instead, what they did was, okay, well, why don't we just make it binary? You get the address of the function that you need to execute, and you impose a very heavy, very structure on it, so that when it actually does get executed, it becomes part of that program no matter what language. And just to prove it to you, I have some Python code here. So you just, it's very simple. So Excel actually is a COM object. So you can use this function called ensure dispatch to get an Excel application. And essentially, as soon as you create excel.visible equals true, Excel would pop up. And so now I have a way of driving Excel from any language by just using an interface that connects to a COM object. The other thing that they said was a must was that the components had to be dynamically loaded. And what do I mean by dynamically loaded? So, take this for example, right? So I want everyone in ISSessions to read a book, right? What I can do is I can buy this book for every single member of ISSessions, okay? And essentially, or put another way, I can have process A get library A, process B also get library A, and process C also get library A. Or what I can do is I can put this book on, I don't know, Google Drive, and then I can just give you the link and you can point everybody there. So a process that is searching for a DLL essentially says, okay, well, I'm looking for, let's say, the iShell link interface. So I'm going to create an instance of that. And when a process creates an instance of that, that process is going to go in the registry. It's going to look for where that interface or the co-class that implements that interface is on disk. And then what it's going to do is it's going to return the path for that DLL that's on disk, and then that process is going to load that DLL. And just remember that this is all in binary, and these processes, this can be a Python process, it's going to be a C process, whatever. Okay. So a lot of stuff I know, but when I said let's go down the rabbit hole, I meant let's go down the rabbit hole. And it's important to understand all this stuff because it's important to understand kind of the history behind some of the decisions that were made and how those are being abused by an attacker. So now that we understand COM, we needed to get to the COM svcs.dll. And the COM svcs.dll is called it's the COM plus DLL. So I couldn't understand COM plus without understanding COM, and I couldn't understand COM without understanding the Win32 API. So it's great that now we can kind of call anything from any language, but Windows then realized that, hold on a second, well, the developer still has to do a lot of work. So every program that is distributed, every program that has to be accessed across a network by many different users, by many different applications, needs to implement some very basic things, such as role-based access control, client-server functionality, things like application pooling or object serialization. And so they came up with this thing called COM+. And COM+ was also really cool because what you did essentially was a developer would write all of these COM classes essentially, and they would just have to register those COM classes in this GUI called the Component Services GUI. And once they've registered class A, class B, class C in the Component Services GUI, and then they said, okay, well, I want to give this application, which is this random collection of components or classes, role-based access control or application pooling or client-server functionality. They could just simply check some checkboxes and give that functionality. So even actually now, right, when you're writing your code and you want to write a distributed application, you might still have to use like maybe the socket API. Of course, there are libraries that kind of abstract all of that. But this is was like a different approach of doing this. You can literally take any set of classes, glue them together in this component services, and then give them these services kind of transparently. So now the developer only has to focus on business logic. Okay. So now to start coming out of that rabbit hole, let's actually bring it all together. So again, this is all about good intentions being abused. So when I looked at the COM services DLL, which has a whole bunch of classes, COM classes, that implemented something called the COM+ system application. And the COM+ system application runs as a Windows service. And I found that there were 4 classes. And those 4 classes are the instance tracking component, event notification server, the process iteration server, and then something called the debug dump server. Okay. And the debug dump server, of course, was the one that piqued my interest because I was researching process dumping. So the intention was to give developers the ability to debug faulty COM+ applications. So all you had to do is, if your application is not working properly, you would just go into that component services GUI, and then you would just have to right-click on your application and say dump process, and that would create a core dump of that process on disk, which then you can take, off that machine and analyze. Okay, so great. So how did that actually work, under the hood? So it turned out that that debug dump server that I was talking about is called pdump.processDump, and it's itself a COM class. It had an interface inside of it called the IProcessDump COM interface. That interface, of course, had the dump process function, and interestingly and kind of weirdly, all that method did was just invoke run-dll32 on the command line. So I haven't explained what run-dll32 does yet, but basically run-dll32 invokes a function that is inside a DLL on the command line. That function has to be written specifically to be used by the COM services DLL. So in this case, we are seeing the mini dump function getting invoked inside of the COM services DLL. So really, you can just skip everything up here, so the debug dump server and the IProcessDump and all that, and you can just go on the command line and run this, and it will actually create a dump for you. And the way this worked is that the first parameter that you see here, the 999, that's the process ID of the process that you want to dump, which, by the way, does not, for some reason, have to be a COM+ application. 2 is that you give it the path of the dump that you want to create. And then finally, you give it the type of dump. And in this case, if I was an attacker, I would be interested in the full dump. And so that's what the attacker does, right? So they just skip to run-dll32, and they dump any process's memory just by invoking this on the command line. Why is this useful? Well, it's because run-dll32 is a native Windows binary. So if you have a rule that is monitoring for like a custom a dumping kind of process, like you just wrote your own like dumping logic, for example. Well, here's the thing. This would bypass that because this is a signed Windows binary. It's approved by the operating system. To be honest, it's still kind of weird to like use run-dll32 kind of in this day and age, like manually. But you will find that a lot of kind of Windows tools will use it kind of underneath the hood, just like this process dumping function does here. And of course, if you actually take a look at what happens when you run this, you'll see that underneath the hood is actually this mini dump, write dump program. And of course, that comes back to the Win32 API function. So why did we have to understand COM plus and COM and Win32 APIs? Because, well, COM services DLL is the COM plus DLL, which implements COM classes, which implement COM interfaces, which implement COM methods, which eventually come all the way down to a Win32 API function. Okay. So now that I've done that, let's actually reread that sentence. And now hopefully everyone kind of understands, right? So it's a technique for dumping process memory by invoking run-dll32 on the mini-dump function in the COM services DLL. Okay. But enough talking. Let me actually show you how this works. So just before I start, process dumping in general does require administrator privileges, and you need to have the SE debug privilege on Windows. Now, this isn't too hard to get. It's on by default in PowerShell. But the thing is, you can through group policy. So, if you're in an organization, you can actually take away that privilege from all administrators through group policy. And that would be one way to kind of prevent any process dumping from happening in your environment. So that could be like a mitigation. But we're not interested in mitigation for this presentation. We're only interested in detection. So let's think about how many different ways an attacker can abuse this attack, right? So you can use run-dll32 on the command line, right? Just like we saw there. Or I can write my own custom executable. So I can dynamically load the function that run-dll32 runs, which is mini-dump-w. Or I can actually dynamically load mini-dump, write-dump. Okay. So I can do this. So basically, if you just write a detection for finding like run-dll32, like if you see run-dll32 on the command line, send an alert. Well, an attacker can bypass that by just writing their own custom executable and importing one of these two functions. Okay. Actually, sorry, I promised a demo, but I forgot that these slides were here. So to help us with the demo, which yes, I believe is next, we are going to use two tools. One is Sysmon, and Sysmon is just a way of generating logs that describe a process's operations on Windows. And then we're going to use Procmon, and a Procmon analyzes process behavior. Okay, so let me actually show you these two tools in action. So what I'm going to do is I'm going to go over here to my RDP machine. Kurt, I just want to make sure. Can you see my screen?
I can see your screen.
Okay.
So have you moved over to the RDP yet?
Yes, I have. So that should
still see the PowerPoint. Are you streaming from the PowerPoint or the entire screen?
Change windows. So you should see it now?
Yep, good.
Okay, perfect. Yep, so what you see here is, so Sysmon, which is actually monitoring process in the background, is running, and it's going to be generating logs. You see that I have a PowerShell prompt open, and you see that I have process monitor open. So what I did was I wrote a script, and the script is right here. It's called invoke POC. And what the script is going to do is it's going to enable all logging on this machine. It's going to execute the process that I want to execute. And the process that I want to execute is, of course, that function that I showed you earlier. So run-dll32, mini-dump-w, and then I'm going to pass it the process ID of the LSAS process. And just to show you kind of where I got that, so if you just open Task Manager, right? If I go to details, and if I take a look at LSAS, which is right here, so you can see that 672 is the process ID of LSAS. So what I'm going to do is I'm going to dump LSAS's memory, okay? And essentially, I'm not going to show you this part, but essentially, once I've dumped this memory and I have that dump file, as an attacker, I can go and again steal credentials or look for credentials inside of that dump. Okay, so let's actually do that. So I want you to pay attention. So the dump is going to come here. Okay, and then you're going to see all of the stuff, all of the data that I'm going to be collecting. Is the log files that Sysmon is generating, that the system is generating, and they're all going to end up being here. Okay, so here we go. Let me actually run this function. So pay close attention. So right now I am enabling all of the logs that you see here. So very soon that the POC is going to be invoked. So there's just a bit of a delay there for various reasons. And the POC is done. So you can see now I've dumped LSAS, and you can see there's a dump.bin here. Okay. And the POC is done, but we just need to wait a minute now, just because it takes some time for the logs to be written, and we should be able to see the logs right here. Now, in the meantime, though, I will show you what I have here, which is, let me actually close Task Manager, which is what Procmon actually got. And what Procmon actually viewed here or detected was that runDL32 was actually accessing lsas.exe. And this is going to become important very, very soon. So let's just wait for that, for those files to be generated. Maybe in the meantime, I will show you. So if I actually go to create file mapping here, and if we look at the stack, what we can see right here, so the U means user mode, and then the K means kernel mode. And we can see, and we read the stack from the bottom up. So we see runDL32, runDL32 again, we see that mini dump W function. And then that mini dump W function turns out to just be a wrapper around the mini dump function. And the mini dump W function is in our com services.dll. The mini dump write dump function is in dbg core. And this is going to become very important very, very soon. Okay, so a few things to keep track of. So runDL32, we see a wrapper function, that's the mini dump W function, and the mini dump write dump function. So I've already showed you all that stuff actually in the PowerPoint. How did I find all of that stuff out? I did it by actually looking at what Procmon was doing, and then there was a whole bunch of obviously like blog posts about this, and that's how I kind of connected the dots. So now that I've gone through the Procmon output, I'm going to show you the Sysmon output. And I have a feeling this is going to be pretty noisy because I forgot that Task Manager is on. I did not close it, but that's okay. Blow this up. Yeah, 3,000 events. Task Manager produces a lot of events, but hopefully maybe we can try to find, let me, 1 second. Let's try to just get one. So only 3 processes were created. Okay, and you can see here right away that we can see on the command line, so this is what we got from that tweet, that the com services DLL was used. Okay, and so now that we have this log, we can maybe start building a detection. Other logs that are kind of really interesting are, let me actually show you. The process access log. This is going to be so noisy. Okay. Yeah, but basically, so unfortunately, I'm not going to be able to show you this, and I've already taken way too much time. But essentially, what you should be able to see, so this is a process access event. And a process access event essentially shows you, okay, when a process accesses another process, but it also shows you the call trace that you see here. The problem is it doesn't show you the actual functions, it only shows you the DLLs. So at some point here, if we look at the right log, unfortunately there are quite a few of them, so I can't show you. But what you would see is you would see exactly what Procmon gave us, minus the function names. So you would see this whole thing here. So you would see runDL32, you would see com services DLL, and you would see dbg core. And so now we can begin thinking about, okay, well, there are a whole bunch of events that are being generated. I have a process one event, which is, a Sysmon event ID one event, which is a process create. And then I have a process access event. And that process access event is showing me that, run DLL32 is accessing lsas.exe, which is a high value process for an attacker. So let me go back to the PowerPoint and let's think about how we want to actually build the detection. Okay, just pull this up. So I've already told you about Sysmon event ID 1. So we see a process create event, so mini-dump W, run DLL32, comment services.dll. All of these are strings that we can look for when we build our detection. We also see these event ID 7 events, and the event ID 7 events are image loads. So that's comm services, the comm services DLL being loaded by that process that needs to do the dumping. And then there's the dbg core.dll, which actually implements that mini dump write dump function, which is a Windows API function that almost every process that needs to dump another process needs to go through. And I've already mentioned the process access event. So we see that run DLL32 is accessing LSAS with an access mask of 1FFF. This corresponds to process all access, which can only be achieved by having that SE debug privilege that I spoke about earlier. And then in the stack trace, and this is really the most important part, we see the comm services DLL and we see dbg core.dll. And then there's also, I'm not going to go over this, but it's the security event ID 4656. Which it kind of repeats what Sysmon event ID 10 does. Okay. So now let's actually think about how we want to write the detection. So we can do this in a number of ways, right? I can just look for mini-dump W on the command line. But again, remember, I showed you a whole bunch of different ways to use this technique. So if I just use the command line method, that would be pretty bad, right? Because then an attacker can just use a custom executable. They can write their own code. They can import one of these two functions and essentially dump process memory, and I would never detect it. So my focus was to try and go for try to build a detection based off of the process access event, since that is really at the core of what is happening. And I know that I have comm services.dll and dbg core.dll in that stack trace. Okay, so essentially what my detection would look like, really, this is just a repeat of the stack trace that I showed you. My detection would be is that if the following conditions are met, fire an alert. If you see that in the stack trace of a Sysmon event ID 10, you see dbg core.dll, right? And if you see an access mask indicating that SE debug privilege of 0, hex 1 FFFF, right? If you see those two things, then it is very likely that a process dump has occurred in your environment. And that's something that maybe your analyst needs to know about. So initially I thought, well, let me just kind of write this, right? I don't want to specify a target process. I don't want to specify lsas.exe, right? But then depending on your environment, right, you might have to tune this later. So maybe you want to create a blacklist, right? So you might want to say, okay, well, I'm only going to trigger an alert when you see one of these two processes, so SSH agent or lsas.exe, right? And so maybe you want to alert only on process dumping on production servers, not development servers, right? So these are kind of tuning opportunities that you would look at later, but first you have to test the rule and see what happens in your environment. Why would you have to do the tuning? Is because maybe your environment is full of C++ developers that dump processes all the time. Then this rule would not be very good. But why would a developer dump LSAS? Or why would a developer dump SSH agent? That doesn't make sense. That shouldn't be happening. So maybe you can make a stronger rule that only monitors for these two, but then you're kind of risking, okay, well, what if I have another high value process in my environment that I'm not tracking? And then finally, does this catch all process dumping? Hell no, right? There are a ton of other methods that you can use. There's the PSS capture snapshot method, which actually does not dump the process directly, does not access the process directly. It creates a handle to that process, creates a copy of that process, and then it dumps the copy. So you actually never see a process access event. So in that sense, you would have to write some sort of aggregation or correlation. You would have to look at multiple events or multiple log sources in order to write your detection. And then there's the C# method, and this actually just came out like maybe 3 days ago, and actually by the same guy who's Samir, and it basically bypasses the detection that we have up here. Because it doesn't, again, show DBG core or comm services, for example, in that stack trace. And that's it for me. I am so sorry for taking so long. Does anyone have any questions? And thank you to everyone who invited me to speak today, and the new exec team.
Lula, you never failed to impress. Because we are running a bit short on time, if you do have questions, please post them in the questions channel. I'm going to say take a break. I really want people to get up and stretch. So we're going to take a 5-minute break. And then when we return, we'll have our guest speaker, Laura, presenting her Bloodhound 101 talk on attacking Active Directory. But I guess if you do have questions, you can talk during the break. But 5 minutes, everybody. Be back at 8:40, please. Thanks, Luai.
Thank you, everyone. And again, sorry for taking too long. I told you I blabber.
That was great. Learned a lot.
Dude, that talk was so sick. Thank you so much.
Thank you, Jim. Did everyone feel like, I know like this is a lot of stuff that we don't really cover in our program. Did I explain it well? I feel like I went probably into a lot of detail on things I shouldn't have gone a lot of detail on. But hopefully, you still enjoyed it. And hopefully more detail is good. Maybe it incentivizes you to go and explore yourself.
Oh, it was great. I definitely know a little bit about PowerShell and, things that I couldn't do in PowerShell and I had to do in Win32, the API. But you definitely shed some light on that kind of abstraction process. Does that make sense?
Mm-hmm.
Lua, I had a quick question.
Sure.
So you know how you were talking about the detection process? Would it be a possible detection, say to combine the two, so the looking for the process and looking for the strings from the stack?
Yes, exactly. So that's what I meant at the very end there. So there are certain ways to create a process dump such that you don't actually generate the DBG core string or the comm services string in the process access event. So
Right.
Now what you would have to do, for example, is you have to say, okay, well, if I see event ID 1 and if I see event ID 10 within 1 second or within 2 seconds or whatever, then you can, again, you can have a very strong indicator that a process dump has happened. The problem with that, though, and the problem really with any correlation or aggregation, is the fact that you have to. It's actually very computationally expensive. So think about, like, let's say you have an environment that's full of, it's a very large environment. You have like 200,000 machines, right? And every machine has 250 processes. And so now your number of processes, numbers in the millions. Basically, the query that you're aiming to write is, well, I want you to check every single second for every single process, for every single machine, for every single user.
Right.
And that will very quickly eat up all of the memory, in your logging cluster, for example.
100%.
Right. So yeah, it's a very difficult thing to do. You have to kind of be very specific in what you're looking for.
Gotcha.
Yeah, to be able to write a rule like that.
Okay, interesting. No, but I think you definitely did a great job at explaining it. Learned a bunch. Loved your demo. Great.
Laura, are you here?
Yep, I'm here.
Hi.
Hi.
I'm going to try attempt to start the stream and see if it works well.
Let's go ahead and do that. If you can. Ooh, it's not good. Why?
Did you want to stream a PowerPoint or your entire screen?
Yeah, PowerPoint. Actually, screen one. Okay. Me. Oh, this looks not perfect.
Looks good to me.
Cool.
Is everything good on your end?
Yep. It's good on my end. Again, remember for the demo, I'm going to switch over to my other account. So just FYI for the people on the call.
Okay.
Yes, Laura did mention that. So everyone who's on the call, so just so you know, Laura's using 2 accounts. So at one point when she does do the demo, everyone will have to switch over to that account, please, to that stream.
Sounds good. So.
Oh, right. Yeah. So only MatSprite basically does some work on the back end. Everybody else just stay on MatSprite stream.
So let me introduce Laura real quickly. We're thrilled to have her as a guest speaker today. We appreciate it quite a bit. Just to give you some background, Laura Harris is a security consultant at CIBC and also a recent graduate of her postgraduate degree in network and system security. She has been in security for roughly 3 years, taking on several different roles, and some of them include security consultant, and security analysis, and a pre-sales engineer. So Laura will be giving a presentation titled Bloodhound 101, Attacking Active Directory. When you're ready, Laura, take it away.
Cool. It's always a pleasure to have talks on cool offense.
Yeah, thanks.
So yeah, we can get started. So welcome to Bloodhound 101, or Active Directory Discovery with Bloodhound. So to kind of give a little bit more of a background of myself, I am a security investigator at CIBC, so I am on the blue team side, dealing with both L2 and L3 incident response. Consider myself a bit of an upcoming pen tester / red teamer. So just like you guys, I'm actively learning offensive techniques, team tools, and so on. I'm also a volunteer for Hack Student, T3X, and DerbyCon, and my Twitter for those who want to follow me. I don't post too much. I'm more of an info lurker with my Twitter account, but feel free to follow me regardless. So just kind of a run through what we're going to talk about today. We're going to talk about what is Bloodhound, the idea of 6 degrees of separation, briefly talk about Active Directory, and then how to use Bloodhound, a quick demo, and takeaways. So what is Bloodhound? Bloodhound is a really cool cybersecurity tool that came about, I believe, in 2016, and it was kind of like a big stepping stone for the cyber world. It's an open source tool, and it's a post-exploitation tool, which means that you can't really get any benefit out of Bloodhound unless you've established some form of a foothold in the domain. Bloodhound uses powerful graphs to visualize different attack paths that people like pen testers, hackers, red teamers can use within Active Directory to reach some form of a goal. In most cases, it's to get the domain admin account, just because it pretty much has the keys to the kingdom in an enterprise. In the back end, Bloodhound sits on a Java application that is built on top of a graphing database called Neo4j. Neo4j is pretty cool. It pretty much just takes whatever data you throw at it and makes relationships, paths, and any associations with it. So kind of looks something like this, with different nodes, different objects, and different lines kind of linking them together. So Bloodhound was built on kind of a concept and idea that all people are 6 or fewer social connections away from each other. So in this particular case, Mary wants to talk to Bob for whatever reason, but they don't know each other. So what she's going to do is she's basically going to use her social network to connect with people and ask around until finally somebody in her network will say, oh yeah, I know, Bob's uncle, let me connect. And that's pretty much the same case in a virtual setting in Active Directory. If you want to get to a domain admin, pretty much you want to just start querying other machines, other objects until you are able to reach your goal. So Active Directory, I'm pretty sure most of you are aware of what Active Directory is, but for context sake, it's just a Microsoft tool that I believe almost every enterprise uses to manage different devices within the network. So Active Directory is pretty hierarchical. So the domain is at the top and all the other kind of objects underneath it will kind of flow. So things like users, groups, printers, shares, and so on. And the domain admin sits at the top with the keys to the kingdom. So how do we use Bloodhound? I kind of decided to lay it out in 3 easy steps. So step number 1 is to compromise a machine on that domain. Again, I mentioned Bloodhound is a post-exploitation tool. So as an attacker, you have to have established a foothold inside the domain to a domain user. So because this isn't really how to compromise a machine class, I'm just going to give a couple examples of what you can do in order to get to that stage. You can use a phishing attack that has some form of an attachment that once the user opens it up, it will spawn a interpreter session. And then with that interpreter session, the attacker can run whatever commands you want. If you're doing a red team or a pen test, you'll more than likely be using Cobalt Strike, and you would have established a beacon to your target. Or if you want to use the responder tool, you can use that as well to steal authentication credentials in order to begin to move laterally. So step 2, like I mentioned before, Bloodhound sits on top of Neo4j, which is a graphing database. What do databases need? They need data. So in order for Bloodhound to give you any form of valuable information, you have to provide it with data. So we're going to run Sharphound, which is Bloodhound's ingester tool, or AKA data collector, on your compromised machine. So you can either run Sharphound or you can run like your own customized PowerShell script that will run things like invoke user hunt that gathers all net sessions, or you can develop your own to go and crawl and ask queries to the AD. So in this case, once you run Sharphound, you'll be able to gather all of these things like local admins, groups, active sessions, users, any trust relationships, any RDP sessions. So that's step 2. So we compromise our machine and we basically scrape for any information that we wanted to provide to Blood. So this is kind of how it looks. You can download Sharphound to your compromised machine, and then you can choose to either use the default or basically collect specific stuff. So at the bottom, if you can see Sharphound, collection method group, local group RDP, means that we only wanted specific information. But if you do the default, it will basically give you everything. Running Sharphound will basically take between a couple minutes. to a couple hours, depending how large the domain is. Step number 3 is to ingest and build. So basically, the data that we collected with SharpHound usually end up being a CSV. So we'll take those CSVs, upload it to Bloodhound, and then Bloodhound will build these attack paths towards your end goal, which is domain admin. So this is just a kind of like a generic image of once the data is ingested into Bloodhound, how it's going to be portrayed to you. Each line kind of shows a different attack path that you can take, but you'll be able to see a bit more clearly during the demo. So again, just to visualize what happened, my graphing/art skills aren't that great, so please bear with me. So on the right side, we have our attacker, which is either using a Kali Linux VM or using Cobalt Strike. And on this side, we're going to be running Neo4j and Bloodhound. And on the left-hand side, we have our compromised machine in the domain that we got a foothold of using a interpreter session. And then we ran SharpHound to collect the data. So just kind of like a visualization for you if you didn't get the previous ones. So demo time. So I'm going to switch accounts. So just FYI, I'm going to stop sharing on this one. Okay, am I good? Can you guys see it?
Looks good on my end.
Great. Well, let me just log in super quick. So I'm just going to move up to make sure you guys can hear me. So to start off, just kind of installing Bloodhound, you usually just want to just run a sudo apt-get update because Bloodhound is already in Kali's repository. So you just want to make sure it's in the packages that you have. Cool, we're good. Then we're gonna do apt-get install Bloodhound. And this is gonna install Bloodhound and Neo4j, which is our graphing database. So to start the database, all we have to do is run Neo4j console. So this is going to start your database, and it's going to give you an interface link, which you can just drop in the web browser so you can get a nice UI. So here, this is our remote interface selection, and then we're going to navigate to the web browser. So because I've already logged in most cases, if you're a new user, it's going to prompt you to enter your usernames and password. It's going to be Neo4j and Neo4j for the password. Definitely recommended that you change your password as soon as you can, just to make sure that no sensitive data is exposed. So now that the database is up, we open a new tab, and then we're going to run Bloodhound. So here you can see that Bloodhound is connected to our database, and it's going to be the same username and password that you used for your Neo4j account. I'm going to just change this to dark mode because this does not look very cute. Okay. So this is kind of what interface you're going to get as soon as you log into Bloodhound. It already has data in it because I imported all of the files that I got from the Sharphound collector. So you can either drag or drop whatever files that you got, or you can click import or upload data. So whichever of these two options will basically give you the data that you need. So on the left-hand side, we can see how many users we have, how many computers, how many groups, ACLs, and relationships. So a big thing to note is, as a normal human being, it would be impossible to visualize 33,000 relationships. So this is a big benefit to Bloodhound, that it maps these relationships for us and kind of picks out the most important ones, and it saves us time during pen testing engagement. Cool thing is Bloodhound has pre-built analytical queries. So it does have the option for you to write your own raw queries, but in most cases, all you need is already pre-built for you. So it's a really cool benefit. So let's start off. So in this particular domain information that we were able to scrape with Sharphound, we want to query if to find all the domain admins. So this is what this one was. Let's see, let's change it up a little. Cool. So on the right-hand side, the yellow kind of guy with the three guys is going to be your groups. And then the green will be your user accounts. So in this case, Jay Wilson is a part of the domain admin group as well as administrator. So as a pen tester, as a red teamer, we want to get to Jay Wilson. So what we can do is we can right click it and mark user as high value, because this is our target. Another cool thing is if you just highlight over the link, it tells you if it's a session, if it's a member of, or if you right click as well and do help, it gives you information about that node. It tells you what it is, how you can abuse it, OPSEC, and any additional references if you need additional information. So we're going to right click and do, no, we're not going to do user as owned as yet. So we're going to go back and we're going to go down to find domain admin logon to non-domain controllers. So if you didn't know, if you log onto a computer with your domain admin account, this automatically places those credentials in the LSAT in memory. So anybody else who has access or admin rights, not anybody who has admin rights to that computer, can basically dump those credentials and reuse them and basically impersonate that domain user. So we're going to click on that, find domain admin logon to non-domain controllers. It's going to be a little bit cool. So here we have Jay Wilson, a domain admin, logged into two servers that are not domain controllers. You can know it's a server by just clicking on the node, and it will basically tell you it's a server, or has the password been reset, or how many sessions, and so on. So it's a really good information tool. So from here, we want member two to also be a high value target. So because we can't get to Jay Wilson directly, we're going to find a path to how we can get to member two. Because if we get to member two, we can just dump the credentials from LSAS and then impersonate Jay Wilson. So we're going to right click. Oh, I always forget. Right click. And we're going to do what's the shortest path to member two. And here we have like this crazy graph that basically gives you different paths that you can take in order to get to this spine. So you usually want to go from left to right. So I'm just going to pick this stream up here because I can't really go through each one. And this is going to be the stream that we're going to use to eventually get to J. Wilson. So to explain this, Carly Roberts is an admin on member 2. Karen Fields has generic all privileges to Carly. And the generic all privileges basically just gives you full control to Carly's account. So if Karen wanted, she could basically just reset Carly's account. Karen has a session on PC1, so another session. Over here we have help desk, so a help desk group, and there's 2 members a part of it. One is Victoria Cook, and another one is Robert McLean. So starting from the left going across, let's say, for example, during our engagement, we were able to own Victoria Cook's account. So we want to do mark user as owned. Now we know the simplest path to get to domain admin is to follow this path here. So what we want to do is we want to set Victoria as our starting node, just because this is the account that we compromised. So you want to set her as a starting node. And then our target node is going to be J. Wilson. Because how do we get from Victoria's account to J. Wilson? Change the layout, give us something a little better. The other way around. Perfect. So as you can see, I'm like changing it up so you can change out the layout however you want. Again, so Victoria Cook, we'll go through the order kind of like on how to compromise. So Victoria Cook, we have her account. We're impersonating Victoria Cook at this point. Victoria Cook is a member of the help desk, which is an admin on PC1. So because she has administrative rights to PC1, she can basically dump all the credentials that are on PC1, including Karen Fields' account. So now that we have Karen Fields' password and credentials, we're going to impersonate Karen by moving laterally. So now we're at Karen Fields. We're impersonating her, and we know that she has generic all privileges to Carly. This basically means we're impersonating Karen, and we're just going to go in and manually reset Carly Roberts' account to whatever password we want. Again, we're moving laterally again. So now that we have Carly Roberts, she's an admin to member 2, which is the Windows 2019 server. And again, as mentioned, if the domain admin is logged on to a machine and somebody else who has admin rights has access to that machine, they can easily dump the credentials. So from Carly, move laterally, we dump the credentials, and now we have access to J. Wilson's account, who is a domain admin. And as a domain admin, you can basically dump all the credentials for all the domain users. So you have, again, keys to the kingdom. So that was kind of like a quick review of how to go across. But for some further information, here, like I said, we'll give you info on the node. It will tell you how you can abuse it, like how to steal the passwords. If you want to do a different method, you can do token impersonations if you don't want to do a password dump. For OPSEC, it will tell you how you can get detected. So if you want to read up more about that, then you can do that so you make sure that you're being as stealthy as possible. And if for whatever reason you don't really understand how to do a particular method, it literally gives you different instructions and different resources that you can go and read about, which is, I find, really great because we're not perfect. We don't know everything. So sometimes we kind of just need to go and verify a reference. So yeah, that's it for the demo. Just some cool takeaways before I kind of end the session is Bloodhound can be used to identify complex attack paths that would otherwise be impossible to quickly identify. So what would have taken an attacker, a pen tester, a red teamer a really long time is taking literally a couple seconds or a couple minutes. A good second takeaway is that defenders can use Bloodhound to identify and eliminate these attack paths. So it's not just like a red team side tool. And in general, both blue team and the red team can use this tool to kind of gain a deeper understanding of how privilege relationships work in an ADU environment or in whatever environment they're investigating. And I have a couple of resources. I'll probably share the slide deck over for those of you who are interested in Bloodhound or want to read up more about Bloodhound, or maybe setting up your own like Active Directory environment that you can then run Bloodhound on. So I'll send that over, and then I guess you guys can share it amongst you guys. But yeah, that's about it for me. If you have any questions or concerns, feel free to ask them.
Yep, up for questions. If anybody has any, you can post them in the questions channel as well, or you can unmute your mic.
Hey, Laura.
Hey.
So I don't know if you could go back to it, but it was I think the second map that you showed us from, I think it was member 2 all the way, you said left to right. I just wanted to know, could you kind of explain why exactly you picked that path at the very beginning, not any other path to choose from? Or
Yeah, so I just ended up choosing that one because you kind of want to start from like the lowest hanging fruit.
okay,
That particular case, that was the lowest hanging fruit, and I'll show you.
gotcha.
Second, let me see. Oh, I hate when it just auto gives me out. So I'm just like, nobody wants to see that.
All good, all good.
Say, for example, if you started down here,
Right.
under the sysadmins group, you would have to just somehow and magically gain access to Guy Williams. There's no kind of like trajectory.
Okay,
Like,
I see what you mean.
just
Okay.
start with them, and
Mhm.
most can't just start with them. So you'd be jumping around blindly in the network until you get to Guy Williams or any of these other ones.
Gotcha. Okay, that makes a lot of sense.
Yeah, so it's just kind of like what is the easiest route, and this in particular was the easiest route for us.
Makes sense. Appreciate it.
No problem.
Dummy Testo has a question. He asked, does the domain admin have to stay logged in for the credentials to be seen in a memory dump?
Does the domain admin have to stay logged in, meaning do they have to still be active?
Yep.
Session? No, actually not. As long as they just logged in for that day, it will save it for that certain amount of time.
So is it like, how long is that something you set in Windows in like policies or something?
How long it stays in memory, realistically speaking, but I can go back and verify for you and let you know.
Laura, I actually have a question as well. So you mentioned that Sharphound is the way that Bloodhound actually collects all the data,
Right.
correct? Or okay, so is Sharphound like an agent that gets deployed on every machine to collect that data, or is it using like PowerShell remoting or something like that?
So it just has to run on one machine, so the compromised machine, and it will basically kind of go in and start making connections and kind of start querying on its own. So it'll start querying like different domain controllers, different clients, different endpoints from that single machine.
Is that
Okay.
extremely noisy?
Absolutely. It's really noisy, but there's different methods and different like commands that you can use to make it more stealthy. It's definitely recommended for you to kind of customize your own PowerShell script that will do it to be less noisy. There has been instances, I was just talking to a friend recently, in a big organization, he was doing a pen test and they ran it like plain and nobody detected anything. So it just really depends if the organization has security tools searching for that particular kind of trigger.
You could also try like dumping it in different areas of the network and then combine them all in logs.
Yeah, absolutely. Like you definitely don't want to save the files and call them Sharphound files.
Yeah, no, for sure. Any other questions? Okay. I guess with that, thank you, Laura, very much. That was extremely informational. Thanks everybody for coming. I will post any information Laura gives me. That is something I want to put on the website as well. And with that,
Sorry, one more thing, Kurt, if that's
Go
okay.
ahead.
Yeah,
Sure.
I just want to mention that earlier today, actually during the meeting, Laura said to me that the content that we have here is very, very good, and that she wants to come back every 2 weeks or so. So I just want to say that her presentation definitely added to how great the content was, and we hope to have her speak again very soon at the ISSessions. So thank you so much, Laura.
For sure. I couldn't agree more.
Content is pretty valuable.
That's what we strive for, and we really appreciate you coming and not only learning, but teaching, right? I don't know about you guys, but I'm tired. It's getting late. Sorry we went a little over time, but considering you're all still here, I'm sure you enjoyed it as well. With that, I'm going to meeting adjourned. Call it.
Cool. Thank you, guys.
Thanks
everyone
everyone for coming.
Thank you everyone for coming.
Lou, I knew you said you'd go long.
Yeah.
But I didn't realize you weren't joking.
No, I was joking, but
oh, you were joking.
Okay, so okay, what ended up happening was like, okay, you understand that like a lot of the stuff I talked about is not taught in class like at all, right? So basically,
yeah, sure.
I would keep hitting things in the presentation where I was like, oh shit, nobody probably knows what this is. And so then I would go in like a deep dive on it, and then it basically like I ran a test beforehand, and it was like 32 minutes. So I was like, oh, no big deal. Like I'll just cut back a little bit or whatever. But yeah, that totally like went differently than what my test was like, because I kept getting this anxiety attack that I was like, oh shit, nobody knows what I'm talking about right now. I need to explain more.
No, I definitely appreciated that. I think that was smart thinking, to be honest. Like, it's a good call.
Yeah, we've been.
I'm sorry. No, you don't have to say that. I am so sorry. I should not have gone that long.
We didn't go that over.
Yeah,
we
like last.
So it was like 10 minutes. Okay,
Dude, you literally went like 4.5, 5 minutes over. I think it was a solid talk. You have nothing to worry about. It was 5 minutes over. You finished at 9:35 or 8:35. Like, you're good. You killed it.
Okay. Thank you.
Yeah, and I liked how you explained it. Like, I had no idea what COM is in those Windows API, and you finally explained it to me. Like,
yeah, man.
Yeah, thanks, Y. It's honestly good work.
You killed it. You went all out. There was a lot of stuff, not just stuff that you explained, but also you gave us stuff to go and do our own deep dive. What is that? What you called it? Do our own deep dive on, right? So
rabbit hole, yeah.
Rabbit hole. There you go. You gave me many rabbit holes tonight. So for that, I thank you.
For sure, and that's what this news segment's about, right? You learn something new, you want to share it with people. It's like, we can't talk about it with people,
True,
it's hard
true.
to.
It's also, I don't know if you guys like experience this as well, but like I don't know.